Hello everyone, my name is Huang Hong Chang. Today I will present Melops, a cross-platform ASR tool I built for automatic subtitle generation. This project started as a course assignment where I needed to create accurate subtitles for technical lecture videos. Additionally, I have been wanting to build a laptop-first captioning tool to help me learn languages and make better use of my new laptop. Let me show you what I achieved. I processed 48 hours of lecture audio in just 15 minutes, almost 2 full days of video content processed in under an hour. Let me show you the specific numbers. The performance is 65 to 75 times real-time speed. A 30 minutes video takes only 30 seconds to process. This runs on an Intel Core Ultra 9 laptop without graphics. Not an expensive workstation, just a normal laptop. I use this to process 79 lecture videos from UC Berkeley and MIT computer architecture courses, all processed locally with accurate subtitles. How is this possible? Melops is built on four core technologies. First, cross-platform design. It runs on Windows, Linux, and macOS through Rust, which compiles to native code without interpreter overhead. Second, it focuses on consumer hardware. You don't need NVIDIA GPUs or cloud service. Intel, AMD, and Apple devices all work. Third, it is 15 to 30 times faster than Whisper models, using NVIDIA's Parity TDT model optimized for speed. Most ASR tools assume you have NVIDIA CUDA. Melops use Onyx runtime to support multiple backends. OpenVINO for Intel, DirectML for Windows, CoreML for Apple. This makes ASR accessible to everyone. Now let me show you Melops in action. I have two demo videos prepared. The first shows the processing pipeline. The second shows subtitle quality on actual lecture content. This, this demo shows the complete processing pipeline. Watch for the different stages. The command is simple: mail download followed by a YouTube URL. The tool downloads the video, extracts audio, and converts it into the required format. Now let's look at subtitle quality. This is actual lecture content from CS61C at UC Berkeley.
My name is Dan Garcia, and I'm so glad that you're part of the 61C class. This is the Great Ideas in Computer Architecture. Woo! Great to see everybody. This is the normal introductory lecture that we are changing around this semester so that we jump right in and get into number representation. But I wanted to make sure you got this material anyway. So this is an extra online lecture we're asking every student to watch to kind of get a free lecture so we can get a little bit more ahead with the projects.
The subtitles have proper punctuation and capitalization. The timing is comfortable for reading. This quality comes from two things. First, Parity TDT has native grammar support built into the model. Second, the grouping algorithm finds natural sentence breaks for readable subtitles. Let me show you detailed performance benchmarks. This chart compares Melops to other ASR implementations. The vertical axis shows real-time factor. Higher number means faster processing. Starting from the top, AD video on CPU gets 8 times real-time. Melops on CPU gets 16 times, 2 times faster through code optimization alone. AD on Intel NPU got 41 times. Melops on Intel Arc GPU gets 65 times. The Arc GPU is more powerful for this workload. Onyx ASR on NVIDIA T4 gets 77 times. The T4 is a data center GPU. The Melops on a consumer laptop is competitive. Fluid audio on Mac M4 Pro gets 110 times. Onyx ASR with TensorRT gets 227 times. Both are faster, but cost significantly more. Melops achieves 65 times real-time on affordable consumer hardware, good enough for batch processing entire courses. But how is this possible when consumer hardware has less compute power? This chart shows theoretical compute power in teraflops, trillions of floating points operation per second. The Intel Core Ultra has 9.6 teraflops. The NVIDIA T4 has 65 teraflops, almost 7 times more compute power. But look at actual performance. Melops gets 65 times real-time. Onyx ASR on T4 gets 77 times. The performance gap is much smaller than the hardware gap. Teraflops alone don't determine real-world performance. Software optimizations and memory bandwidth matter. Melops is heavily optimized for consumer hardware. Now let's talk about cost. Melops runs on a laptop that costs $1,100 and achieves 65 times real-time. Fluid Audio runs on a MacBook Pro M4 Pro that costs $3,100 and achieves 110 times real-time. Fluid Audio is faster, but costs almost 3 times more. Performance per dollar, Melops is competitive. More importantly, 65 times real-time is fast enough. I processed 48 hours in 15 minutes, practical for batch processing entire courses. The answer to why Melops performs so well is the model choice. The model choice is critical for both speed and accuracy. Let me show you why Parakeet TDT was the obvious choice. This is the Hugging Face Open ASR leaderboard, which benchmarks models on accuracy and speed. Parakeet TDT 0.6 billion version 3 ranks third in accuracy among the high inference speed models. Parakeet has several advantages beyond just speed. First, native grammar support. The model outputs proper capitalization and punctuation, making subtitles readable without post-processing. Second, better handling of technical terms. Parakeet's LSTM auto-aggressive decoder uses context for enhanced accuracy on domain-specific vocabulary. Third, 6.32% word error rate. That's seventh place on the OpenASR leaderboard. Fourth, 15 to 30 times faster than Whisper models. Combined together, these advantages make Parakeet the right choice for educational content. Here is a concrete example. The speaker says RISC-V, an open source instruction set architecture. YouTube auto captioning says RISC-V. Completely wrong. This happens because YouTube's ASR doesn't understand context. Melops gets it right. RISC-V with proper capitalization and punctuation. You've seen all the RISC-V instruction and the actual bit patterns. This shows recognition result across 48 hours. 297 correct out of 385 instances. Not perfect but usable. Let me explain how Melops works internally. I'll keep the high-level focuses on the design choices that make it fast and portable. This diagram shows the architecture from left to right. On the left, the CLI orchestrates three commands for scrap URLs, download videos, and processing local files. All use YTDLP and FFmpeg for audio extraction. The ASR engine processes audio through Mel spectrogram conversion, chunking, and TDT inference. Results are merged and detokenized. Hugging Face Hub provides the model download and tokenizer. Onyx runtime handles inference with multiple execution providers like OpenVINO, CUDA, and DirectML. The cache system ensures the processing is interrupt-safe. And finally, the SRT generation with subtitle regrouping. I forked Parakeet RS and rewrote it from scratch. The original implementation had no chunking support. First, 30 seconds chunking. Longer audio make attention computation expensive. Chunking make it affordable. Second, remove tensor copies to save memory bandwidth. Third, process two chunks concurrently to keep the GPU running at full capacity. Fourth, duration-based decoding. Skip silence frames using duration tokens. This results 3 times speed up. 30 minutes video now takes less than 30 seconds. Let me show you current setup process and what improvements are coming to make it easier. The current setup using Pixie, a package manager handling Python, Rust, and native libraries in one environment. Install Pixie, clone the repository, run the export command to convert the Nemo model to Onyx, then run Melops with the OpenVINO environment. Pixie creates isolated, reproducible environments with no dependency conflicts. However, this isn't ideal for non-developers, so I have future plans. First, provide pre-built binaries. Right now, Pixie compiles from source, which takes time. Pre-built binaries means download and run directly, especially important for Windows users. Second, publish to PyPy. Melops needs a virtual environment to find Python, FFmpeg, and acceleration libraries. PyPy makes this easier. Third, publish to CondaForge. Conda is popular in data science and education. Fourth, quality of life improvements, like auto-detect models, progress bars, and better user experience. The goal is to make ASR accessible to everyone. Here are the key takeaways from the presentation. YouTube struggles with technical terms, and most ASR tools expect expensive NVIDIA GPUs. With Rust for portability, Onyx runtime for cross-platform inference, OpenVINO for Intel optimization, and Parakeet TDT for speed and accuracy, Melops offer a better solution. You get 65 to 75 times real-time performance on a 1100 laptop, competitive with data center hardware. It accurately recognizes technical terms like RISC-V, and I've processed 79 videos, 48 hours of content in just 15 minutes. All subtitles are public on GitHub. Melops shows you don't need expensive hardware for fast ASR. just good engineering. The project is open source on GitHub and Melops. All 79 subtitles files are available at NCKU.org 2025 subs. For technical details, see the HackMD logs, which cover the development process, challenges, and technical aspects. Thank you for your attention.